Hi. It occurred to me that I should probably do a really quick what the heck is an Arduino uh, little video here. Just to back up a little bit, Arduino is a method of, it's a simplified environment and a set of tools for doing for building embedded systems. An embedded system is just a generally a microcomputer, a microcontroller that is dedicated to a single thing. The computer that's inside of a thermostat or inside of a printer or inside your car, those are all embedded systems. They're there usually to do a specific thing, as opposed to your laptop or your PC, which are more general purpose. Now, before Arduino and similar systems, you had microcontrollers. A microcontroller, this chip here on the Arduino is a microcontroller. The general loose definition for microcontroller is it's basically everything that you need to run a microcomputer, writ small, but all in one package. Typically you won't have gigabytes of memory, you won't have large storage spaces. You do have a you have a CPU, you have some memory, you have some permanent memory, flash RAM or something like that. You also will have I/O and everything, so you can pretty much directly control things all in one little package. Traditionally, if you wanted to do microcontroller development, you would have something like this, which is, this particular one is from Atmel. This is their AVR 500. For years it was the standard for doing development on Atmel processors. It's kind of expensive, it's a little hard to use. Compared to Arduino, it's real hard to use. It's not that difficult for, if you're a programmer, but if you're not a programmer, you're probably never going to get over the learning curve on this thing. So along came somebody that said, well, let's see how simple we can make this, and a team of Italian guys got together and they came up with the Arduino. The Arduino, the main chip in here is not a special Arduino chip or anything like that. It's just a standard AVR Atmel ATmega processor, microcontroller. But it has, usually if you're programming, if you're doing traditional programming on a microcontroller, you usually have to have a custom programming device, like maybe something like this, which is, traditionally was kind of expensive. You could spend several $100s just on a programmer. These days, everything's a little cheaper. This is a $60 or $70 programmer, but that's all it does, is it just programs chips. It doesn't do anything other than that. And you had to have that in order to put a program on this chip. What Arduino does is it has what's called a bootloader. It's a little program that's always on the chip. When you first turn it on, it spends a couple of seconds listening on the first couple of pins to see if somebody's trying to send it a new program. And you can do that over the USB. The USB, this is the chip that talks to your computer, between the computer and the processor. So you turn the thing on, or if your computer sends is trying to send a program, it can through the USB force a reset on this controller, forcing it to look to see if there's somebody sending out a program again, and then it can send the program over. The bootloader also manages taking the program from the USB and sticking it into permanent memory, and then the bootloader also provides some basic functionality that normally you would have to write all manually. That's another thing that the Arduino environment gives you, is it handles a lot of the just little fiddly junk. You could almost think of it as a really tiny operating system for a microcontroller. It handles all of the I don't want to get into technical terms here, but it handles all of the low-level stuff, interrupts and things like that, which you might eventually want to start playing around with those things, but having to deal with interrupt service routines and programming prescaler counts and things like that, and directly fiddling with registers. These are all things that you have to do if you're programming, doing traditional programming on a microcontroller. You have to spend probably hours reading the data sheets for the chip to figure out what bits to poke into what registers in order to turn on the output value, a certain pin as an output. It's a real pain in the neck, honestly. Arduino saves you from all of that. Now, Arduino, by saving you from all that, it imposes certain limitations, but those limitations are surprisingly easy to live with for a lot of stuff. So Arduino gives you that, and Arduino also gives you the development environment here. And the real win with Arduino is, to use a kind of a marketing term, it's the ecosystem. That means that you've got the hardware, you've got this development environment, but you also have thousands of people who have already done a lot of work for you. You don't have to figure out how to write code to talk to an accelerometer, because somebody's already done that, and you can just grab their library, install it in the IDE, and go with it. So it really is. It really makes development quite rapid. I'm going to real quickly also show you. This is what's called a shield. That's Arduino's term for it. You notice that the pins line up with the pins that are on there. This is a prototyping shield, and you can just stick it on, click it on top of the Arduino. This gives you a little bit of a breadboard that you can put parts into. There's a few switches you can wire to, and there's a few LEDs, and if you want to, you can put another shield on top of this. A shield just is, there are hundreds, possibly thousands of shields out there. Some of them are relatively general purpose. This one is the most general purpose one, probably. Some of them are very, very specific. There are shields that are just there to run a specific camera. There are shields that are just designed to run a 3D printer. This one here is called the LOL shield. It's which means lots of LEDs. The guy figured out what's the maximum number of LEDs that I can possibly run with the number of I/O pins that are on Arduino, and this is the answer, basically. And this thing doesn't have any real purpose other than it's a lot of LEDs, and you can, you know, that's all good fun, blinking LEDs. This shield here is a motor controller. You can run stepper motors if you want to start playing around with robotics. It's a good first step. This stuff is surprisingly cheap. I mean, you can buy a motor controller for $10, maybe less, I don't know, these days, and maybe down to $5. But as a way to get started in electronics, it's never been easier or cheaper, or have you had anywhere near as many resources to just go online and find somebody who's already done a lot of the individual pieces. That's the kind of thing that is the challenge these days, is thinking of a new thing to do. All the little pieces that make up that new thing may have already been done. Hopefully they have been done. You can go up and see them, and then your challenge is to think of a new way to put them together into something unique. There's multiple Arduinos. This is one of the older style 2009 Arduinos. There's Arduino Unos, the new ones. It's getting into the point where they're not even all using the old Atmel microcontrollers, AT Megas. The newer ones, there are ones that are using 32-bit ARM chips running much faster speed. There's tiny versions of them. This is essentially the same board as this, but everything's made very small. It's packed in on both sides of the board. You can take this thing, you can stick it onto a breadboard, and you can build it into a product much more easily than you can build this big thing into a product. Now, one thing is that a lot of the stuff that's on this board is just support. The only thing you really need to, once you get your project working, you can actually take this chip off along with this oscillator and a couple of little bitty parts, and all the rest of the stuff here, you don't need it. You can actually build. I've done that a couple of times. You get the prototype working with this, and then you wire up a small version of it with a dedicated chip and oscillator, and you put it in a box and you ship it away to do its thing for the rest of forever. This here is a tiny version of the Arduino Leonardo. It's got this thing can actually talk USB, so you can actually make this thing pretend that it's a keyboard or a mouse or something like that, in addition to doing all the normal Arduino things. This is an Arduino LilyPad. The thing attached to it here is just the programming thing. You don't need to leave that attached. This is actually designed to be sewn into clothing and to control lights, servo motors, whatever the heck displays you want to have as part of your clothing. You want a hat that has some kind of a display on it. You can make one with this, and that's what it's designed for. This one here is a special purpose. It's an 8x8 color display. It's called a Arduino. This thing is actually, it's Arduino compatible, and it's been designed specifically just to run this thing. You can program it with the Arduino IDE, same as any other Arduino. This is an Arduino Mega. It's a lot the same as the other one, but it has a lot more I/O, it has more memory, costs a few more dollars, but even this thing is surprisingly cheap. You can get these for $13 or $14 on eBay. You don't have to use just shields. There's just any number of sensors. This is a RFID reader. You can have little keychain tags that you push up against this thing, and it gives it a unique ID. And you can have one of these that opens your front door when you touch this to the panel. Ultrasonic distance sensors. This is a relay shield if you want to control high power lights or something like that. Bluetooth module for talking to your phone, doing things like that. Wireless for hooking maybe multiple Arduinos together. This is a Wi-Fi module. You can have it connect to the internet through your Wi-Fi connection. There's everything you can think of: barometric pressure, water flow through a hose. There's sensors out there for it, and they're probably less than $10. If you can think of something that you might want to sense, there's probably something out there that you can buy and hook it to an Arduino and use and sense it, and have the Arduino do something based on that. So I don't know if it's been helpful or not, but this is what I've got in front of me right now, and I hope that you guys have fun learning Arduino, and I hope that maybe the stuff that I'm putting up is helping you in some way. See you later.